algebraically, a function is decreasing if for any values of x, say x of 1 and x of 2, such that x of 1 is greater than x of 2. So the definition of a decreasing function starts out just like the definition of an increasing function. X of 1, you choose x of 1 and x of 2 so that x of 1, the first number, is greater than the second number. But it doesn't end up the same way as the definition of the increasing function. We have x of 1 is greater than x of 2, but f of x of 1 is less than f of x of 2. This is the definition for a decreasing function. This is the algebraic definition of a decreasing function. This means that if we just have the equation of a decreasing function, if we just have the equation of a function, we can tell whether that function is increasing or decreasing just by looking at the equation. This means that we don't have to have the graph of the function. We don't necessarily have to graph the function to tell whether it's increasing or decreasing over a certain interval. Now, if you have a problem involving a function and you want to decide whether the function is increasing or decreasing, you have to choose your two numbers for x of 1 and x of 2 such that x of 1 is greater than x of 2. Then you have to substitute those two numbers in the function for x so that you can find f of x of 1. When you substitute x of 1 into that function, you will find f of x of 1. When you substitute the number for x of 2 into that function, you'll find f of x of 2. And then, of course, you can determine whether or not f of x of 1 is smaller than f of x of 2. Notice that the numbers have flip-flopped on us here. The x of 1s and x of 2s have flip-flopped. Here we're saying x of 1 is greater than x of 2, but then over here we're saying that f of x of 1 is less than f of x of 2. So this is the case for the decreasing function. For example, suppose we have this function. Suppose we have the function f of x equals 2x squared plus 1. We want to find out whether or not f is increasing, decreasing, or remaining the same, constant, over the interval from negative 10 to negative 4. So this is the interval that we're looking at, negative 10, negative 4. We want to know whether it is increasing or decreasing over that interval. So first of all, we have to set up the relationship between our two values of x of 1 and x of 2. Now we said that when we start out that x of 1 would be greater than x of 2. That's what we said. X of 1 would be greater than x of 2. The interval we're talking about is negative 10 to negative 4. That's the interval we're talking about. Now x of 1 has to be the greater value of the two numbers that you're talking about. So in this case, with x of 1, would it be negative 10 or would it be negative 4? With the greater number, be negative 10 or would it be negative 4? We have to make sure that when we set the problem up that the first condition is true, that x of 1 is greater than x of 2. And that's where we have to choose our numbers. If you said that x of 1 is equal to negative 4, you're right. Because negative 4 is greater than negative 10. So we start out with this. Negative 4 is greater than negative 10. And that is true. That's true. Now, to decide whether the function is increasing or decreasing over that interval using algebra, now we have to find f of x of 1 and f of x of 2. We have to find f of x of 1 and f of x of 2. If f of x of 1 is less than f of x of 2, if that is true, then the function is decreasing. If it's not true, the function is not decreasing. If it's not true, the function is not decreasing. It might be increasing or it might be a constant function. If that's not true, since this evidently is true. Now, to find f of x of 1, we have to substitute the value for x of 1 into our original equation. So f of x of 1 would be equal to f of negative 4. F of negative 4, remember the original equation was f of x equals 2x squared plus 1. That was the original equation. So that means that to find f of negative 4, everywhere we have x in this original problem, in the equation of our function, we have to substitute negative 4. So I will substitute negative 4 here where I have x, and here I have x squared, so I would have negative 4 squared. So that means that f of negative 4 is equal to 2 times negative 4 squared plus 1. 2 times negative 4 squared plus 1. Now we have to simplify this. Negative 4 squared would give us 16. 16 times 2 would give us 32, plus 1 would give us 33. This is what we get for f of negative 4. Now we find f of negative 10. This means that at this time, to find f of negative 10, everywhere we have x in our equation, we substitute negative 10. This is how you find f of negative 10. So that gives us f of negative 10 equals 2 times negative 10 squared plus 1. Negative 10 squared is what? 100, right? 100 times 2 is 200, plus 1 would give us 201. So that's what f of negative 10 is equal to. Now, we have found f of x of 1, and we have found f of x of 2. For the function to be decreasing in that interval, we've already shown that this is true, that x of 1 is greater than x of 2. That's the way we chose our two numbers. Now we have to find out whether or not this is true. F of x of 1 is less than f of x of 2. If it is true, then our function is decreasing. So we found out that f of x of 1 was equal to 33. And we found out that f of x of 2 was equal to 201. 33 is less than 201. Is that statement true or false? That statement is true. 33 is less than 201. So that means that this is true. X of 1 is greater than x of 2, and this is true. F of x of 1 is less than f of x of 2. So we say that therefore since x of 1 is greater than x of 2 and f of x of 1 is less than f of x of 2, our function is decreasing. F, the function, that's the name of the function, is a decreasing function. Once again, our final conclusion is that since x of 1 is greater than x of 2, we've shown that negative 4 is greater than negative 10, and f of x of 1, which is 33, is less than f of x of 2, which is 201. Since both of those are true, the function is a decreasing function.